Okay, today we're talking about uh, the calculus for physics. And so, we have our typical position, velocity, acceleration graphs. And today we're going to talk about how we go from one to the other using calculus. So, we spent first semester doing slope and area. So, if you go from position to velocity, so far we've done, if you take the slope of the position graph, you get velocity. Well, now we're going to talk about taking the derivative. Taking the derivative is taking the slope at some moment in time. Going from velocity to acceleration, you also take the derivative. Now, going from acceleration, going back up instead of going down, so down d, you take the derivative d. So kind of a pattern there. Going up, you take the area. And so if you have acceleration and you want to find the velocity, you take the area. Well, the area under the curve is the integral. And so same thing, trying to find position from velocity, you take the integral. And so if we look at that, the equation to find the velocity, if you take the derivative of the position, we have dx dt. And same thing for acceleration. Acceleration is dv dt. Going up to take the integral, we have velocity is the integral of a dt, and position is the integral of v dt. And so you can use these relationships with functions. So anytime you see a function, you're going to want to use calculus. If you have a graph, you use the area and use the slope. So a couple of other relationships. J is what? So here we have impulse. We have Newton seconds as our unit. An impulse is also equal to the change in momentum. So you could have either one of these used interchangeably versus time. And if we go down, we take the slope. Well, if you take the slope, you have Newton seconds over seconds. That gives you units of newtons. And so taking the derivative of this function would give us the force. And so you can kind of use the units as a guide. If you put the y-axis over the x-axis, what are your units? And so if we have a force versus time graph, when we studied momentum, we had this kind of graph, and we found that finding the area of this gives us the impulse or the change in momentum. And so another word for the area under the curve is the integral. And so if we look at this function, force is dp dt. And so if we look at that change in momentum for, with respect to time, we can get the force. Going up, if we take the integral of f dt, we get impulse, or we get the change in momentum. And if you use the units to guide you, the unit of force is Newton and the unit of t is time. And so a Newton second is an impulse, or also the unit for momentum. And so the last one we're going to look at, kind of notice this is the only one where you have x instead of t on that y-axis. And so there's a lot of similarities between these two. We have force versus time, and this is force versus position. And so notice the difference between those two. So if we start out with potential energy or work versus x, and we want to find what's the force involved, we can take the derivative. The opposite, if we have the force with respect to x, and we want to figure out what's the energy, we can take the area under the curve of that graph and find the area under the curve, which is the integral. And so the force is du dx, and the work or potential energy is the integral of force dx. And so something to note about this, I want you to kind of notice right here, this little negative sign. That little negative sign is important, and that's something that a lot of students miss. So something that can help you with this, if you're not quite sure, You can take a screenshot of this or make a note card or flashcard with this. But something that's really helpful is if you use the units to figure out whether you need to take the derivative or the integral of that function. If you're looking at taking the derivative is the same thing as the slope. And so if you divide the y units by the x units, does the unit of that match what you're looking for? Or do you need to take the integral? And so the integral is like the area. If you multiply those two things, do you get the correct units? So another thing, these graphs are also interchangeable with our rotational motion graph. So if we have theta here and omega here and alpha here for angular displacement, angular velocity, and angular acceleration, those are all the same. You can take the derivative of theta to get the velocity. You can take the derivative of the angular velocity to get alpha, or the angular acceleration. And so those apply kind of the same. So y'all have a great day.